Whenever talking about photogrammetry, accuracy is always a consideration for us, regardless of the project. We want to know that the photogrammetry solutions are accurate such that we can take measurements out of those solutions and know that those measurements are accurate. With lens distortion being present in a photograph, the camera matching photogrammetry or other kinds of photogrammetry can often be difficult or really impossible to get good solutions out of. So it's important to always remove those distortions wherever possible. At Kineticorp, our first step is to look at the EXIF data on the photograph. Now, EXIF data is the metadata contained within the image file itself. So within that image, there's header information or metadata where you can see what camera was used, what the settings were within that camera, the field of view, that kind of thing.
Most of the lens distortion removal that we do is using software that already has the profiles for lens distortion. It's caused by the curvature of the lens. And there's a big long equation you can calculate out the actual distortion and use that to remove it. And there's programs that do that automatically.
If you're stuck with an image that doesn't have EXIF data, which happens to us all the time, we get images that are provided that have been saved out as a PDF, which strips out typically all the EXIF data, and then you don't have the information about the camera. When you're stuck with those kind of images and you're trying to perform photogrammetry on those, it can be really problematic, if not impossible. We had photographs that we knew had lens distortion in them, visible lens distortion, but we had no EXIF data and therefore no great methodology for being able to remove that distortion. So out of the result of that frustration, we began studying ways to remove that distortion without the EXIF data. The first one is what we refer to as a straight line method, where we look at the photograph and determine are there any lines within this photograph that should be straight, edges of buildings, telephone poles, street lights. The second method is the point cloud method. We use a scanner, a 3D scanner like a Faro scanner or a Leica scanner, anything would work, to document the scene and really encompass it with a point cloud of data. That data is accurate. I'm thinking of the Faro scanner right now, plus or minus 2 millimeters. So you have an accurate representation of that 3D environment that you can then take and compare specific points in the photograph to or against and know that, look, here's the true world measurements, here's measurements in the photograph, which is not accurate, and then in comparing those, you're able to remove the distortion based on that. You should consider lens distortion. It's not that it's going to affect every camera match or every photogrammetry solution, but if you're not considering it, you can potentially achieve that much error in your solutions or have that much error in your solutions, and that can be problematic.